What's going on, my fellow astrophotographers? My name is Asher St. Nick, and in this video, I'm going to be giving you guys a brief overview on how I do astrophotography. One of the things I'm going to be talking about in this video is polar aligning, calibration frames, the stacking process, and that is about it. I'm also going to show you guys my equipment that I use. I actually have two telescope setups, but tonight I'm going to be just bringing the more portable setup because this is actually going to be a very special video as well, because I'm going to be shooting a comet tonight. I'm not going to be doing any deep space astrophotography. All right, guys, we have arrived. I'll talk a little bit more about my setup once I get everything put together. It's not going to take me that long because this is a very portable setup, but I will talk about more about this in a second. But one thing I want to talk about real quick is just the area that I'm in right now. And I also kind of want to talk about the Bortle scale. So first off, I'm basically in an open field right now, surrounded by a bunch of small businesses and stuff right now. And I've been coming out here now for like the last year and a half, and I've done a lot of major projects in this location. I've shot the California Nebula, Pac-Man Nebula, a bunch of globular clusters, and I also shot the most recent comet a couple months ago in this location. And this morning I'm going to be shooting the Comet PAWNSTARRS as well in this exact location. And the reason why I come out here a lot too is because it's half decent skies compared to where I live in, and that kind of, explains a lot of my pictures sometimes and how detailed it is, with some of the stuff I can capture. And that's because of the Bortle scale that I'm in. So what exactly is the Bortle scale? That is a numerical scale ranging from 1 to 9, and that's just measuring how much light pollution is in your area. Number 9, of course, is like city lights, of course. That is basically a lot. Obviously, there's going to be a lot of light pollution. And then Bortle 1 is going to be truly dark skies with no traces of light pollution at all. Each number on the scale is also represented by a color. I believe 3 is like green. I think 4 and 5 are like yellow and red. And I believe 8 and 9 are like white. This area particularly is a Bortle 4 sky. Bortle 4 and 5 skies are typically rural skies, so you're basically out in the countryside, of course. And I can actually see a lot more stars than I can typically see back at home. Where I live is a Bortle 7 sky, so some of the stars that I'm seeing right now, like if I'm looking at Ursa Minor right now, and I could still see like the 2 handle stars, including Polaris. But when it comes to like looking at the stars that make up the rest of the handle, I normally can't see those stars unless I point binoculars or something in that part of the sky. So you can kind of already, I can already tell a difference right away. And like I said, I've shot some major projects here before. There are some cons though, especially if I'm imaging an object that's like closer towards like more meridian. So typically when I'm in this area, hopefully when I'm shooting something, it's more zenith and stuff too, because Bortle 4 and 5, there still is light pollution in this area, but you kind of want to be more pointed up because you kind of invade some of the light pollution if you're in that skies. Obviously, Bortle 7, no matter where you're at in the sky, when you're looking at the sky, you're going to be dealing with light pollution all over the place. So let me head back up and let me go over my telescope setup that I'm going to be using. So let me give you guys some visual examples right now. So first off, we have Ursa Minor right here, by the way. You got the 2 end stars right here that make up the Little Dipper. Can't really see the other stars in the constellation, but right there where my finger's pointing, that's actually Polaris. And essentially, the telescope mount right now is facing north, and there's a little small reticule that I have to look through to be able to map myself in where Polaris is. And there's a little hole right off to the side right here. You can probably see it. Basically, when you look through the reticule, you'll be able to see Polaris. Probably not, just because I don't want to touch anything. But if I get everything aligned correctly, that right there is the reticule, by the way. You can't really see Polaris because it's a small. You can't really see it because I'm not going to put my phone completely up against it. But that's what the reticule looks like. And there's an app on my phone called PS Align. So basically, what I'm doing is I'm looking through the reticule and I have to match Polaris up in that spot. Once I do that, I'd take a picture, and then once I know that I'm getting round stars, then I know that I'm polar aligned. And like I said, the idea of polar aligning is essentially following the Earth's rotation. So you can take pictures and take long exposure pictures and get nice round stars. If you don't do that, you're gonna get star trails. And what I mean by star trails is if you take a picture right now, if I took a picture right now without doing the polar aligning, the stars will be stretched, and that's because of the Earth rotating. And it's kind of crazy that, you know, a 24-hour rotation doesn't really seem that fast, but it is. And it's also kind of cool too at the same time, because you can kind of actually visually see the Earth rotating, besides just looking at the sky, you know. Also, it's starting to clear up now. It's actually looking pretty promising now, so hopefully it stays clear. Also, let's just look at the rest of the sky real quick and just kind of go over what's out right now. So obviously, that star right there is Vega, by the way. This right here is the constellation Lyra right here. I don't know if you guys can see the other stars that make up that constellation. The Ring Nebula is in this part of the sky. I see other parts of the Summer Triangle too. This right here is Cygnus, of course. Obviously, you got the Veal Nebula, North American Nebula, and a couple other open clusters as well. This right here, we have Aquila. Like I say, you can't really see much of the other stars, but that's Aquila. This is all part of the Summer Triangle. Also, there's two other small constellations as well, Sagitta and Vulpecula. The Dumbbell Nebula is like pretty much sandwiched right in the middle, right here. There's also a couple other planetary nebulas that are in this part of the sky too. Cygnus, you also got the Fetus Nebula, and I already mentioned about the Ring Nebula as well. There's also a couple other globular clusters as well. M56 and M71 is on this part of the sky. Let's face this way now. Let's go over here. We got part of Scorpius right here, by the way, ladies and gentlemen. This star right here is Antares. Messier 4 is located right here, and then you also have the Rio Ophiuchi complex as well too. That's a very notable deep space astrophotography target that I still have to image. If I look straight up, guys can see the square of Hercules right here. Let me zoom out. I don't know if you guys can be able to see it, but you can kind of see the square. Right up here is Messier 13 is located right here, and right off to the side, if I zoom out a little bit more, you can't really see it, but M92 is located right there as well. And if I turn over here, we got Leo on this part of the sky as well, starting to set, of course. And then you got a couple of other. I just seen a shooting star right now. There's a meteor shower going on right now too. So there's a lot going on right now. I know I'm just blabbering in my mouth, and I just identified a lot of constellations without even using stellarium because I've been doing this for a long time. Getting off topic, but yeah, it's mid-April and the summer, let's just put it this way, the summer constellations are rising up this late at night, so, or this early in the morning, I should say, so it's almost time. So later in this video, I'm going to go over light frames, calibration frames. Probably not going to do it right away just because actually see a satellite right now. I don't know if you guys can see that. Just seems like a satellite. This right here is Sagittarius, by the way. You can see the teapot right here. Also, right where my finger is pointing right, by the way, is where M22 and M28 is located. And then right around this region right here is where M8, the Lagoon Nebula, is located, and the Triffin Nebula, M20 as well. And then right on this part of the sky right here, we have Scorpius, by the way. That right there is Antares, Messier 4, and Rio Ophiuchi. The molecular complex is located right there as well. And higher up here, we have M80, right where the star is located, or at least right about here. Alright guys, I am back. I am now on the computer. I'm actually going to do a little bit of editing too in this video, just so you guys have a better understanding on what's happening. Also, I do apologize if there's anything that I'm missing in my video, just because when I had intentions of uploading this a couple of days ago, and what ended up happening was I ended up deleting some of the videos that I put onto my phone after I started recording. And as soon as you use your, let's just say as soon as you delete any of your videos that you use and you're using the iMovie app, it's going to desynchronize everything in that video, and you're not going to be able to actually upload it or watch it anymore if you delete any video that you added to that specific video file. So I'm starting off scratch. So right now I have Deep Sky Stacker open up. This is a good time for me to get more in depth with calibration frames. So right here at the bottom right here, you see light frames, dark frames, flat frames. We're going to ignore dark flat frames and bias frames because I don't take those pictures, and those I would say are more optional. So I'm not going to get into any detail of those at all. But let me first get into light frames. So light frames are literally the exact pictures that I took out in the field this past Saturday, of course. I'm shooting this other half of the video on April 24th, which is, yeah, so, whoops, let me zoom back out. So I used my Canon EOS Rebel T7 or my DSLR camera to shoot all this. I'm just trying to zoom in into the Comet real quick. So there is the Comet that I shot early in the morning. I think this was probably around like 5 o'clock in the morning or so. I only had probably 15-16 minutes worth of data and stuff, and you'll see all of that coming into play once I start stacking. But basically your light frames are your pictures that you're taking of whatever object. This is not the final picture, and the reason why I have a stacking software, because the end goal here is to get everything, combine all these images into a single picture with a total exposure time. Because, and you'll see why, because if you see this, you can kind of see the comet tail a little bit. You can kind of see the green part of the comet as well. There's not really much going on, but once I stack all of this data, by the way, it's going to bring up the comet tail, which you'll see later on in the video. And I shot this with a Red Cat 51, so it's a small refractor. I think the focal length on it is 250 millimeters, and the aperture is 4.9, so it's a very wide field. It covers so much area for us. So your light frames are literally just the pictures that you're taking pictures of, and hence the word light. Dark frames, so if I go scroll all the way down, it doesn't really matter which one. Basically, your dark frames are basically these. After I get done with a session, your dark frames are basically your pictures that are going to remove the noise in the picture. So if you don't know what I'm talking about with noise, if I actually zoom into one of my light frames and stuff, you can see all, how it looks noisy. You see all those little specks coming up now as I zoom in. That's noise. And the idea of dark frames, it's supposed to essentially remove those, remove the noise to make it more have more resolved, or have a more resolved picture. So normally the way you take these is dark frames. After I'm done, I just put the cap right back onto my telescope, and then from there I just start taking the same amount of exposure time that I did with my light frames with my darks. Each light frame, by the way, was 30 seconds. And this is after I polar aligned and made sure everything was correct. And you know, for the most part, it was getting nice round stars. Also, you can kind of see a couple other background stars too in the image. The reason why this picture looks the way it does is just because it was during sunrise, and so there's a lot of light pollution, but you'll see later on in the stacking process that, and once I start actually doing some editing, I can kind of make this more darker and the stars and the comet tail will come into view. And then finally, I just want to talk about flat frames. So what exactly are flat frames doing? I'll do this. Bring this up a little bit more. So essentially, this is a flat frame, and that just removes any disfiguration in the picture. So literally, if you look at the bottom right here, you see that little smudge mark. So it removes like any dust particles that build up onto the cap of the telescope or the camera. So essentially, it removes all that. And if I go to one of my light frames, by the way, you can kind of see it too. So the flat frames are going to remove anything with disfiguration or smudges due to dust particles and stuff. And also, everything was uploaded in these 3 files right here that I created. Of course, I connected my camera up to the computer, and basically what I did then was just create folders, and then when I open up Deep Sky Stacker, it basically, so hit files, and then it gives, and then from there I just have to select whatever files the pictures are in for everything. All right, so the next step normally after I get all my pictures uploaded is I will do register check pictures. Whoops, gotta check them all. So check all, and then I'm gonna register my pictures. So basically what this is doing is just detecting. So this is going for the light frames. It's just registering your light frames in. So the software essentially will read the background stars, and then essentially will give you a number. So it reads 163 stars, and essentially it's just registering pictures that you want to get ready to stack, and then it gives it a score for each light frame. And if a light frame score is very low, that can be due to many things. The telescope just wasn't focused, or the polar alignment wasn't perfect, so you're starting to get star trails. Basically, the software is just trying to pick the best pictures to stack. One thing I do want to mention though is, since I'm doing a comet, I'm not going to start the stacking process right away after these pictures are done being registering, because this is not a deep sky object. And what I mean by deep space, I'm talking about galaxies, star clusters, so on and so forth. Since this is a comet, the apparent motion of the comet is much different compared to the background sky itself, because obviously the comet's much closer and it's moving much faster compared to stars. So if I were to stack it right now, which is kind of cool by the way, you'll kind of see the apparent motion of the comet moving. So the comet itself looks nice and round, but what's going to happen is if I actually just start stacking, the comet will just get stretched. So the way I combat that is basically selecting the comet position, and you'll see more about that after these files are done registering and stuff, and I'll go more in detail about that as well. But the end goal here is, what I'm trying to do is get the final image from my light frames, and we're going to get one single image in this picture. I'm going to get a single picture once all these pictures are combined. And the idea here is to bring out more faint detail that you normally can't see in a single image. And that's the whole point of stacking, and it also makes the picture look much prettier. Once I'm done on Deep Sky Stacker, I'm then going to move on to Photoshop. But I'm going to do this as a step-by-step process on how it's all done. Alright, we are now going to start selecting the position of the comet in every picture. So if I come over to edit comet mode, and I've already did it for all my pictures by the way. So basically what I would have to do is anywhere it says right here, select the comet position. So basically I just have to select wherever the comet is, and then from there I just hit save changes. So then I'll go through each light frame, and the reason why I do that is, as you notice, you've seen how the comet's now over here. That's just because I had to move the telescope over a little bit to make some fine adjustments while I was shooting this comet. But I would go through each light frame to select the comet position, because I've already mentioned before, if I actually did not do any of this and I just started stacking this, the comet will get stretched. So by doing that, I'm pretty much telling Deep Sky Stacker where the comet is, and once it starts combining all these pictures into one, the comet's not going to be stretched. It's just going to overlay it by overlaying each picture over wherever the comet is. So, and also, as I mentioned before, the reason why you register this picture is because it gives each light frame a score. It doesn't give any of the other calibration frames like your darks and flats scores, because those are not your actual pictures that you're taking. So I don't really have like a rough estimate. Like this light frame right here, this is a pretty low score because you can kind of see some of the trees coming into view right here. These are all trees. So so something like this might not get stacked, but I've already did my first two pictures already, and I definitely will tell you all 32 of these pictures will get stacked. If it was like obviously really bad quality, the stacking software will eliminate that picture for the final stack. So now if I come over to stacked checked images, it gives me an estimated total exposure time for each light frame. So that's 16 minutes, so I was right. Like I said, I've done all this ahead of time with the actual stacking and stuff. So now, oops, I forgot to select the recommended settings, but I think it should be okay. So normally at the bottom left corner it said recommending settings. Normally I would just select whatever type of settings I would feel. Actually, let me stop this real quick. So if I go back to stacked checked images, if I go to recommended settings right here, basically I can choose whatever parameters that I want to choose for everything, just to make sure that, you know, everything stacks correctly. So it gives you like different options and stuff. And everything that's highlighted is everything I have selected, of course. So once that's all said and done, then it's going to start stacking each picture. So it's, as I said already, I already knew that it was going to stack all 32 images because I've already stacked 2 pictures, and I've already done 2 pictures already. And the first time I did the stacking was just with, I think, 21 pictures, but I decided to use the full 32 just because I want to be able to get better images. So the more pictures you have, the more integration time you have, the better the picture is going to be. Likewise, if you have the camera sensor open, so if I wasn't just taking 30-second exposures, let's say I just bumped it up to a minute, you're going to be giving the camera more time to collect the light and stuff too. More photons, better picture, better quality. So but the reason why I was shooting 30-second exposures is because of how low the comet was during the sunrise, of course, very low in the sky. And I was shooting this one ISO 800 as well. That's just how bright I want the image, by the way, because if I haven't mentioned that already. So normally longer exposure pictures are typically better for like low dim objects like emission nebulas, dim galaxies like M74, M101, and M33. Faint reflection nebulae around like the Pleiades, for instance. So typically, yeah. So what the stacking software is doing now, it's stacking all 32 pictures, and then everything is going to be combined into one image. I'm not going to save this picture because I already have the actual stacked image already saved, so I'm not going to do it. I just wanted to like illustrate of what it's like to actually go with the typical workflow. This is like, I guess the best way I can explain this is like the typical workflow that I usually do when I'm doing my editing and stuff. And usually I'm dealing with a lot more pictures because I'm a deep sky astrophotographer, so I do a lot of deep space. I don't really do anything with the planets and stuff, so this is actually going pretty fast. And like I said, I've already stacked all these pictures already ahead of time, so this typically would take me a lot longer, mainly just because of selecting the comet position. So, and this comet was very green on my camera too. It's a very green comet, but every comet's got their own unique characteristics and composition, you know. So it's computing the final picture. So this is the stacked image, of course. And you're going to see a hell of a difference in a second once I actually pull up the stacked image on Photoshop. So the stacked image is what I'm going to be actually editing and stuff too. So all those 32 pictures, I are not going to be getting editing. Some astrophotographers will do some light edits on their light frames before stacking, but unfortunately, I'm not that person that does that. I'm one of the people that tend to just get right to it. Also, there's a lot of stacking softwares you can use. I use Deep Sky Stacker because it's free and it's very easy to use. You also have like PixInsight, which does a really good job with producing pictures. I just don't know how to use it because that's a major learning curve on how to use it. Then you have Sorel. I do use another, if I'm doing like moon stacking and stuff, I'll use Star Stack It, I think it's called, or I forget what it's called, but there's like another software that you normally use for like planets and the moon, and I use typically 2 stacking softwares when I do my photography editing and stuff on the computer. But Deep Sky Stacker is obviously more geared towards deep space and comets and stuff. And then the other one is for the planets and of course the moon. Once this is all said and done, I'll be back in a second once this is actually done stacking. So once the picture is done being stacked, you get a single stacked image, of course. I mean, obviously this is very overlit and stuff because of all the light pollution and the sun rising, which doesn't really help. But, yeah, so. But yeah, this is when it's done being stacked, and then normally after your picture is done being stacked and once you start editing it, you're going to get essentially a black image. So this is the same picture from Deep Sky Stacker, but the reason why it is all black is because I have to go and actually do the editing now or pull out the information, and this will kind of help me dive deeper into like the histogram portion of this video. So now I have Adobe Photoshop, and then I'm just going to pull up that exact image. I'm going to go to, it was CR3 Final 2. I'm going to open this picture and then actually start the editing and stuff. So your histogram is right here. So this was also on the DSLR camera too. So basically what I'm going to have to do here is actually start doing some curve stretches and start bringing out more of the white lighting. So on the right side of your histogram right here, you have black or white lighting. So this is where all the information is in the picture. And then right here, you have this is the black lighting. So what I'm gonna try to do is pull out some information by doing some curve stretches and stuff too. But before that, I normally start off by going to mode and make sure it's selected as a 16-bit channel. And then I'll go to adjustments, and then I'll make sure to go to HDR toning, and then I just make sure I select it as exposure and gamma, and then I'll hit OK, and then I perform my first curve stretch. So I go to adjustments, curves, and then I just slide this tool up a little bit, and you can kind of see how it's starting to move towards the right a little bit. And these different channels of colors, by the way, are red, blue, and green. So, and then once I start doing that, let's actually zoom into the color. Let me put my phone down real quick so you guys can see this. You can actually see a little bit of the comet tail coming out of here. Let me zoom back out, by the way. I'm actually going to let's crop this down a little bit to make it more easier to do this, because I shot this, and the reason why the comet looks so small is I shot this with a small refractor and stuff, so that's why. Just for my crop real quick, and then let me zoom in by pressing Control Plus. Okay, so now what I'm going to do now is, as you see, I'm moving it towards the right where the light is, and then the dark lighting is on the right side, or so is on the left side. So if I want to, and I don't want to keep it overexposed, because what will happen is if I keep doing like these curve stretches and stuff, as you can see, it's just blowing up the picture even more, which I don't want to do that. But let's it's kind of like, and you want to kind of just even it out. So I'm going to perform a little bit of a levels. Levels is essentially going to bring it down toward and make it darker. Also, since I have a little tool on here to remove the gradient from the light pollution from both skies, and what that's going to do is it's going to even out the RGB colors right here, and then makes them look more natural and stuff. Let me actually turn off my light real quick while I do this to make it easier, so you guys can see. All right, so now got everything nice and dark. I'm going to do yet another curve stretch, because there's still a lot of stretching I can do in this picture. And then I don't know if you guys can see this or not, but you can kind of see the comet tail coming into view now. And this is literally the reason why we stacked these pictures, because if I went on the Photoshop and did this with a single light frame, you're not going to see much. Check that out. You can see the comet tail coming into view. So let me hit OK. So at this point in the video, it's just me doing the actual editing portion now. I usually, so this is the stacked image that I'm actually working on right now. So perform another curve stretch. I can still do that. And then doing that. And once again, you always want to pay attention to how far this goes, because if it goes all the way towards the right, and then I perform like, and then I do, and I try to even it out with the levels, it's going to be too noisy, so you got to be careful. And then I think that might be too aggressive. We'll see what happens. Oh, perfect. See that? Look at that comet tail. Check that out. That is literally the comet tail. And also you can kind of see some little discoloration, but I'll do another gradient tool. So if I come down to RC Astro gradient exterminator, that should even that out. No, it doesn't. So what I'm going to do is I just crop this out like so. So just like this, so. Boom. Boom. All right, let's do one more curve stretch. As you notice, it's starting to get slightly noisier now. So do one more curve stretch, and then should be it. You see that? This is what I mean. You see how all that noisy? So, okay. And then I'll perform one more levels. And then what I'm going to do then is try to bring out some color now. So there's the comet tail coming into view. There's the comet itself. So now if I come down to camera roll filtering, what I'm going to do is I'm going to try to do some dehazing here and some noise reduction as well. Just a little bit of that, do a little bit of clarity as well. Down a little bit. Then let's go all the way down to noise reduction, and that's obviously removing that. Probably about a 40. And then I'm gonna hit OK. So now what I'm going to do here is I'm going to do another this. There we go, it looks pretty good. And now let's get some color into this. If I go to adjustments, and then if I go to saturation and hue, I can actually give this comet some color. Probably do about a 20, about 30. Check that out, it's starting to look more gray now. And as you've seen in the previous stacked image, you actually guys did not see the comet tail at all. That's why stacking is very important. So this is the comet tail right here, as I said already. Let me go down to adjustments now, and then let's do some vibrance to bring that a little bit. I'm gonna probably put this on a 20. Take that. Slider doesn't want to work today. All right, so I think that looks pretty good. Obviously, this is kind of the point of this video is just to show you what a typical workflow looks like and just kind of give you guys a heads up on how I do the editing and stuff. But yeah, I would say that's a pretty successful image for just 16 minutes of worth of data. If I had more, obviously you'd probably see more of a Comet tail, but since I was in a Bortle 4 sky when I shot this, it wasn't really the best, but also I waited super late to image this comet. I think it's no longer visible in the northern hemisphere. I think after April 20th was like the deadline or something. But anyway, this is pretty much done. I mean, once I'm done, I would typically come over and then hit save as, and then I would go down to save type as Photoshop, and then my Creative Clouds, I would save it under my portfolio and stuff. But I'm not going to do that since I've already done the Comet already, and this is actually my final picture right here. So this is actually my final picture that I shot already. And then there's the Comet tail. Obviously this wasn't the first Comet I've ever imaged, by the way. I've also have shot Comet Lemon. This is obviously my favorite picture I've shot. Don't know why that is like that, but this is Comet Lemon that I shot. And then there's another Comet. I don't think I have it anymore, but there was another Comet that I shot. But yeah, so that's pretty much it. If you guys want to see more of my videos, subscribe to my channel, and I will see you guys next time. Peace out.